Hi there, welcome to my channel. In this video, I am going to discuss about the solution for removing nth node from the end of the list. Let's look at the problem description. We are given the head of a linked list and we have to remove the nth node from the end of the list and return its head. Okay. So let's look at the example 1. So this linked list has 5 nodes 1, 2, 3, 4, 5, and we have to remove the second node from the tail. Okay. So basically we have to remove the node 4. And the final list should have 1, 2, 3, 5. And in the example 2, the linked list has only one node and we have to remove that node. So we have to return the empty list. So in the example 3, the linked list has two nodes 1 and 2 and we have to remove the last node. So n equal to 1. So the last node has to be removed. So the new list have single element which is 1. So the constraints for this problem or the number of nodes in the list is SZ, and which is the size of that linked list is ranging from 1 to 30, and each node value will be ranging from 0 to 100. The value of n is between 1 and the size of the linked list. Let's look at the approach to solve this problem. So the given input is linked list with 5 elements and we have to remove the second node from the tail, okay, which is 4. Okay, and also we have to solve this problem by scanning the linked list only once. So basically we can maintain a 2 pointers which are n number of nodes apart. Basically the n pointer is n nodes away from the starting pointer. So for example, in this case, start pointer is pointing to 1 and the end pointer is pointing at 3. Okay, and then we have to advance. Once the start and end pointers are positioned, we have to advance both the pointers together one at a time until the end pointer reaches the last element. So when the end pointer reaches the last element, the start pointer points to the element before the element to be removed. Okay, and we manipulate the next pointer of the start node, the start pointer, and return the head of the list. So that's what I have written here. First we initialize the start and end pointers to point to the head. Initially they both point to the head. Then we advance only the end pointer n times. So 2 times from here 1 and 2. So the end pointer points here. Then at that point we will have to check whether the end point is null. If so, the start pointer points to the element to be deleted. So simply we advance the start pointer and return that value as the new head. Okay. Otherwise, we simply advance both the pointers together until the end pointer points to the last element. Okay. So when the end pointer reaches 5, the start will reaches the node 3. Then simply we manipulate the start pointer. Basically we remove the element pointed by the next pointer of the start node. Okay. So when this end pointer reach here, the start pointer points to 3. Okay. Then we update the start pointer next pointer to point to node 5. So we'll remove the node 4. Let's look at the flowchart. Input for this procedure is head of the linked list and then the position of the element to be removed from the tail n. Okay. First we initialize the start and end pointer, both points to the head of the linked list. Then in this loop we advance the end pointer n number of times so that start and end pointers, the end pointer is n number of nodes away from the start pointer. Okay. So once that is done, we check whether the end pointer is equal to null. That means the node pointed by the start pointer is the element to be removed. So we simply assign the next pointer of the start node as the head of the new list and return. Otherwise, if the end is not equal to null, then in this for loop we advance the start and end pointer until the end pointer reaches the last node of the linked list. So once the end pointer is pointing to the end of the linked list, then the start pointer is pointing to the node which is present before the node to be deleted. We simply remove the node pointed by the start node's next pointer and return the head of the linked list. Let's move on to coding. First, I initialize the start and end pointer to point to the head of the linked list. Then I write the for loop to advance the end pointer n number of times so that the end pointer is n nodes away from the start pointer. Then I check whether the end pointer is null after that loop. If so, the element to be deleted is pointed by the start pointer. So I simply return the next pointer of the start pointer. Otherwise, in the second for loop, I advance both start as well as the end pointer until the end pointer reaches the last node of the linked list. Once the end pointer points to the last node, then I remove the node pointed by the next pointer of the start node. Then finally I return the head of the linked list. Next I am going to run the test cases. All the tests passed. Next I am going to submit this program. Cool, this program is accepted. Next I am going to do the code walkthrough with sample input. This linked list with 5 nodes, and we have to remove the second node from the tail, which is 4. Okay. So first the start and end pointers are initialized with the head. So they both point to the head. And then in this for loop, we advance the end pointer n number of times. Okay. So the n is 2. So in the for loop iteration 0, the end pointer is advanced once. So it points to node 2. Okay. So at the end of this iteration 0, start points to 1, end points to 2, and then we decrement the value n, so it becomes 1. So in the iteration 1, the end points to 3 and start still points to node 1, and then the value n is decremented, the value of n is decremented, so it becomes 0. Okay. So end pointer is 2 nodes away from the node pointed by start pointer. Okay. So once that is done, we check whether the end pointer is equal to null. In this case it is not null. Then we move on to, then the next for loop will be executed. So this for loop runs until the end pointer reaches the last node. Okay. So we simply advance both start and end pointer one at a time, one node at a time. Okay. So in the second for loop iteration 0, start pointer is advanced and it points to 2, and the end pointer advanced to point to 4. And in the iteration 1, start pointer will point to node 3 and the end pointer will point to node 5. So now the end pointer is pointing to the last node of the linked list. Okay, so then we break out of the loop. Once we come out of the loop, then we have to remove the element pointed by the next pointer of this start node, which is 4. So we are updating the links. We are updating the next pointer of the start node. So the node 4 will be deleted from the linked list, and then at the end we return the head of the linked list. So after removing 4, we have 1, 2, 3 and 5. So that is the expected output. Next, I am going to do the time and space complexity analysis for this solution. Time complexity of this solution is order of n. So let's take a look at the case where the input linked list is having 5 nodes, and we have to remove the second node from the tail. Okay, so this has 5 nodes, and to delete the node 4, how many iterations this for loop and this for loop performs? Okay, so this for loop performs 2 iterations because value n is equal to 2, and this for loop performs 2 iteration, so totally 4 iterations. Okay, so if there are n nodes, then those two for loops combined will perform n minus 1 iterations together. So the time complexity is order of n. The space complexity is order of 1 because no additional space is allocated in this procedure to store the intermediate data. So the space complexity is order of 1. Thanks for watching this video. Have a great day.